In this video, I'll analyze the different light types available in the Unity editor, differentiating their shapes and examining some of their properties. I've got my main Zombie Toys scene open, and it's lit by the default directional light and skybox that were created as part of creating the new Unity project. I'll select the directional light. What we can see is that the directional light is defined by a point in space and rays that indicate which way it's aiming. A directional light, then, is parallel and can be thought of as infinitely wide. Alternately, you can visualize the directional light as a cylinder with parallel rays encompassing the scene. As the directional light is infinitely wide in the scene, we care not where it is, but where it's aiming. That is, the position doesn't matter as much as the rotation of a directional light, so we get our rays in the direction we want. All lights, then, in the Unity editor are defined by at least two components: a transform, found on every game object, and a light component. This light component, then, defines the type of the light, plus other options such as baking, color, intensity, bounce intensity, shadows, cookies, render mode, and culling mask. We can change the type of a light easily by simply dropping down under Light Type, and there we have spot, point, and area, as well as the directional this light already is. To change the lighting in a scene with a directional light, simply rotate that light. I'll press E to rotate, and rotate this light around on the green y-axis, on its local y in this case. What we can see is that the lighting changes on the walls of the room and the floor as I rotate this light. Moving the directional light, then, has no effect on the lighting. I'll create some other lights here, first turning off the directional light so we can see them more clearly. To turn off a light, then, uncheck the light component here in the inspector. This actually entirely turns off that light. Alternately, you can take the intensity of that light down to 0, but it's still being calculated in the scene as it's still on as a component. Next, I'll create a point light. To create lights, choose Game Object, Light, and Point Light in this case. The light is created in the center of the viewport. A point light is a sphere or ball of light, starting in one place as dictated by the transform component, and radiating out to a fixed range or radius. This range is defined by this yellow wireframe sphere here in the scene. To enlarge the radius of a point light, drag any of the nodes of that sphere around. As we can see, by making that light larger, we see more of that light cast on the floor and a little bit of the walls in the room. I'll increase the intensity so we can see it more clearly. The point light, then, functions differently from the directional in that it has a fixed range, so we can use this range, then, to limit how far this light goes and how many objects it will hit, an important consideration for real-time lighting. I'll delete this point light, pressing Command-Delete on a Mac or Delete on a PC, and next I'll create a spotlight. I'll choose Game Object, Light, and Spotlight. The spotlight, then, is different from a point in that it's a cone of light, starting in one place as dictated by the transform component, and emulating down along the local z-axis of that light in a cone. I'll pull this light up, and we can see then that its range and angle are defined by this yellow wireframe cone. To increase the spot angle, or the size of the cone, drag out any of the outside nodes on the bottom. This widens the light. Right now we can't see it because it's not long enough to touch the floor. So I'll drag the middle node, the range, down. We can just see this light on the floor here, giving us a circle of light as it's aiming straight down. I'll bring up the intensity just a little bit, and there's our spotlight. Like the point light, the spotlight can be limited exactly in range and angle to only hit certain objects. I'll pull this light over towards a wall, and we can see it has a marked different effect on that wall. Again, I'll delete this light by pressing Command-Delete on a Mac or Delete on a PC, and next I'll create an area light. I'll choose Game Object, Light, and Area Light. The area light, then, is a rectangle of light. I'll pull this up in the scene and enlarge it so we can see it. The area light is defined by a width and height in Unity units. I'll boost this up to 10 and 10. What we can see is that the area light, as shown in the Light Type dropdown, is for baked lighting only. What that means is that we won't see this light until our scene lighting is baked or pre-calculated. As you can see in the lower right corner of my screen, Unity is actually baking the lighting, but as I haven't marked anything here for baked lighting, we're not going to see much of a difference yet. We use this light, then, to emulate a large surface emitting light, where the rays are all running parallel and the light is very soft, emitting from a larger area versus a single point as from a spot. Again, we'll use this for baked lighting only, where we need maybe overhead lights coming through a diffuser, for example. Like the other lights, this light has a color, intensity, and bounce intensity, as well as render mode, culling mask, and options for flares. I'll delete my area light and then look at the skybox in the scene. I'm going to turn back on the directional light, and we'll really see a difference in here as we change that skybox. Again, I've selected the directional light in my hierarchy, and I'll check Light here in the Light component to turn it back on. What we're seeing is that we've got a default blue sky behind us. This was created again when we started this project. This gives us the ambient light in the scene, where the gradient light in here plus that ground color gives us that overall soft bounce light once we're choosing to calculate lighting. To change a skybox then, go into the VFX folder in the Assets and into Skyboxes. There's a skybox there called Nightmares Procedural Skybox, a deep purple skybox for use later in our game. What I'll do to change this skybox then is to select it from my assets and drag it into any blank area in the view. Dragging it on an object won't change the lighting, but dragging it into that blank area in my scene, anywhere we can see a sky beyond the objects, changes the color of that lighting instantly, and we can really see this on the back wall. Again, I haven't enabled anything for light baking, so we're going to see some change in the ambient light color, but not in any of the bounce light yet. The procedural skybox in Unity then is different from the lights we can create, in that it's defined as a gradient, where we've got controls for the sun, sun's size, atmosphere thickness, sky tint, ground, and exposure. We can change around how this sky looks by playing with these different properties. For example, increasing the exposure brightens up the skybox and correspondingly brightens up the scene. Changing the sky tint and ground then give us different color contributions from our sky in our ambient color that unifies the scene. For example, changing the sky tint over to pink gives us a pink cast on objects in the scene. And again, this isn't showing fully as we're not calculating lighting. Now that we have a good understanding of the different light types available in the Unity editor, as well as their shapes and some of their properties, we'll look at using layers to exclude objects from lighting. This is important in our real-time lighting for optimizing performance, and then we'll start to light our Zombie Toys scene.